5.2, we're actually coming back to linear equations, but they're not really linear equations. They are called linear equations, but these are equations with three unknowns, three variables. So the equation in standard form ends up looking like ax plus by plus cz equals d. They're called linear equations because they look like our linear equations in two variables, ax plus by equals c. But these graphs are not going to be straight lines. These graphs are actually going to be planes. So basically think about an endless sheet of paper that just keeps going in all directions. So this is a three-dimensional equation which can have an example like this, x plus y plus 2z equals 9. And the idea is we will have three axes now to represent each one of those unknown variables. So we've got our x, our y, and our z coordinate. So what happens in this case, basically, think about like a wall like this, which just basically has no bounds. So it's going to keep growing in all directions. It's just this big plane is what you get from each of these equations. So when you're talking about a system of equations with planes, you're basically talking about how can these planes intersect with each other. So just like we saw with straight lines that two lines can intersect at a point, they can be the same line or they can be parallel lines. You actually have something similar with these planes. They can in fact intersect at just one single point. Now it's kind of hard to imagine. I mean, think about taking three pieces of paper, right? And just they're going to be meeting at one single point. So just imagine that with this planes instead of just a small piece of paper. Obviously, the planes can be overlapping. They can be the same like lines, but overlapping planes. So you can have that, which would give you infinite number of solutions. And obviously your planes can be two parallels, kind of like these two opposite walls, right? Because they're going to be parallel, they're never going to meet. One other scenario that can happen, especially when you have two planes only. So think about a wall and a ceiling coming together. So when they come together, they're going to meet at a straight line, right? So if they're going to meet at a straight line, then that means that line again can keep going in both directions. It's an infinite line, which means again, we can end up having infinite number of solutions. So they can be same plane, overlapping planes, which can give you infinite solutions, but also if the planes are meeting at a straight line, you can also get infinite number of solutions. So you can essentially see all three types of examples happening here with planes. The first thing I actually want to do is just give you an example of how graphing a plane works, but we cannot use this to solve our system of equations, because how do you draw three planes that are meeting at a point or a line? So we're just going to do this as a basic idea of how to graph a plane. So with our first example here, our equation is x plus 2y plus z equals 6. And you know how we use intercepts to draw lines? We can actually use intercepts to draw a plane, but in this case, since we have a three-dimensional graph, we need to find intercepts for each of the three axes, okay? Now here's the thing when we're trying to draw this three-dimensional axis. Our vertical one is going to be the z-axis in this case. Horizontal is going to be x, and almost you can think at a 45-degree angle is going to be the y, okay? Because if you try to think about this in terms of three dimension, your x and y plane are actually going to be like this, a flat plane, right? Normally we think of x and y like this when we're drawing them, but in three dimension, your x and y is just this flat plane, and the z is actually the one that gives you your height or depth, however you want to think about it. So my x and y are the horizontal layout like this, obviously meeting at 90 degrees still, and then your z. So the z actually tells you how high or how low that third point is going to be, which means that gives you the direction where your plane will be facing. And what's going to happen is when we're trying to graph this, we obviously cannot graph the entire plane. So what happens is our graph will actually just look like this little triangular shape, because these are the X, Y, and Z intercepts that we're going to find. So they basically become like vertices of your triangle, and you're just able to draw a triangle, which gives you an idea of what the orientation of the plane is going to be. We just cannot draw, because it's really hard, if you think about it, to draw a three-dimensional object on a two-dimensional surface. Think about, when they taught us how to draw cubes, we always draw some of those lines at an angle to show us that there's a depth, but we can't really draw a cube on a two-dimensional piece of paper. So that's kind of what we're going for here. Now, when we are marking our little axes, this is kind of what we need to do. So our X, so I'm actually drawing 6 marks on each side. So that would be, and then for our Y axis, it goes like this. And then our Z, okay, something like that. Okay, so let's try and find those 3 intercepts or vertices for our triangle. Let's start with X-intercept first. So remember, just like we do in a two-dimensional line, if we're trying to find X, we are making our Y and Z values 0, okay? So that means I will have X plus 2 times 0 plus 0 equals 6. 2 times 0 is 0, and 0, obviously those guys disappear, and you end up getting X equals 6. Now these are 3 variables, right? X, Y, and Z. When it's just X and Y, we call it an ordered pair. With 3, we call it an ordered triple, because there are 3 terms. And of course, they're still in the same order, X, Y, and Z, alphabetical order. So that's going to be 6 for X, 0 for Y, 0 for Z. Okay, so ordered triples instead of an ordered pair. Same way, find your Y-intercept. So if we're finding Y-intercept, that means X is 0 and Z is 0. That will be 0 plus 2Y plus 0 equals 6. So what's your Y? Will be 3. So that ordered triple will be 0, 3, 0. Okay. The last one we need to find is the Z-intercept, which means our X and Y values will be 0. So that ordered triple will be 0, 0, 6. Okay. Once we have all of those values, let's see how we can graph this now. So just to help you out with the orientation of these axes, we have positive X on the right-hand side, negative X on the left-hand side. The Y-axis, the positive is actually the one facing us. So your positive is on this side. This is the negative side. Z, positive on the top, negative on the bottom. So it's just really the Y-axis we got to be careful about, because it's the side that faces us, which is positive. So when you have your X-intercept at 6, 0, 0, of course, that's going to be in line with that 6 marker on the X-axis. our y-intercept was at 0, 3, 0. So remember, this is the positive side here. So 0, 3, 0 will be this third marker here. 0, 0, 6. For the z, of course, will be the sixth marker on the positive, right? So those will make the 3 vertices for our triangle, and then you're just drawing your lines from each point. Now remember, it's just showing us a portion of the plane and basically where are the plane edges or something like that crossing the axis, right? Now they talk about you can find an additional point like a checkpoint, and we will do that, but it's really honestly pretty hard to graph that. So let's say if we wanted to find an additional point, and again, just to keep it pretty straightforward, let's just pick some easy numbers for lines. You can actually pick one for y also, and it should give you a point. So that will end up becoming 1 plus 2y plus 1 equals 6. Which will give us so our order triple will be 1, 2, and 1. Now the idea is we're trying to make sure it's going to be on that same plane that we just drew, and this is where it kind of gets a little tricky. So 1, 2, and 1. So that means we're looking at positive 1 on the x-axis, positive 2 on the y-axis, and positive 1 on the z-axis. So it actually comes out to be yeah, it is the worst point to draw. And it took me, when I first did this graph, I think it took me like 10 minutes just to sit there and look at the graph and figure out where I want to put this point. Because again, if I show you with those little pens here, so remember our x and y is on the flat surface, and then this is our z. So we're basically saying 1 on the x, 2 on the y, and z is 1, right? So it's floating somewhere over here, but how do you draw that again on a 2-dimensional piece of paper? So you know what? Take your best guess. Put it somewhere in the middle of that triangle, and I'll be happy. It's not easy. Well, you know, our brains don't visualize 3D and 2D either, right? Our brains are programmed to see 3D images, because otherwise you guys would be looking really flat right now, right? We think 3D. So it's really hard to draw. So like I said, just kind of use that idea of I'm 1, but then I have to come to 2 units for the y and go up 1 unit for the z. So this is my checkpoint 1, 2, 1. Okay?
Basically, as long as it's within the triangle, you put it.
Yeah, sure. I mean, put it close enough. Don't like put it right over here
Right,
where it's not
absolutely.
in the neighborhood, but I think you guys should be fine. Alrighty.
It would actually.
It's actually more to the right.
Yeah, it'd be more on this side of that
Oh, shush.
Z line.
I'm thinking
Sure.
back to my CAD days. It's 1, 2, and then up 1. So it's actually more to the right of the
Yeah,
triangle.
and I had a student tell me that the other day, and I was like, you know, I have seen that explanation also. So, like I said, I'll be happy if you're somewhere in that neighborhood of the points, because yeah, after 10 minutes, this is the best I could come.
I know, I was thinking the same thing. I was looking at my hand and I'm just like, wait a minute.
Yeah, I mean, you think about it, should be somewhere over there, but
Got your z-axis here, so it should be on this side because it's a positive x, and then over here because it's a positive y. So roughly, it would be right here. So it'd be like
yeah, I'm in agreement.
there.
I am not contesting that at all. I agree. So yeah, do your best guess. I don't honestly even know if my math lab will have you do the additional point. It may not, because I don't know how you do that. All right, so I do actually want to look at how to solve a system of equations with these 3 planes. So this is basically the idea that if we had an independent system, which means we should be able to intersect 3 planes at one point. Now, again, like I said, if you can try and visualize that, try it, but this is kind of their interpretation. So this guy is one plane, this is the other one, and then of course in that blue purpley one is the other one, and they're all literally meeting at one point. So how do we calculate something like that? So what we really try to do is use the idea of, if I can break this down from 3 equations with 3 variables and convert it into 2 equations with 2 variables, and I can use what we basically did in 5.3 or even 5.1. So that's kind of our goal here, is to take our system and reduce it down. So they're saying find the easiest variable that you can eliminate. We can use addition or substitution to eliminate the variable. And then the idea is you can use any of the 2 equations. So the first and second, second and third, or first and third equations, whatever combination works. Solve your system of 2 equations, 2 variables, find one variable, find the second variable, and then for the third one, we basically come back to one of the original equations. So with this guy here, number 2, we are looking for one single ordered triple because this is an independent system, which will only have one ordered triple as the answer. So let's see what this guy looks like. Okay, so we've got x plus y plus z equals 9. We've got x minus y plus 2z equals 1. X plus y minus z equals 5. So when they're saying find the easiest variable to eliminate, I'm actually normally looking for variable that either have opposite signs or that will be easy to multiply and get rid of one of them. So you can see y has opposite signs with one of the equations is negative and the other 2 are positive. We also have the same thing with z, but the only problem with z is one of these variables has a 2 in front of it. Y has all coefficients as 1, so y is actually going to be a little bit easier to eliminate. So that's my go-to variable first, is to find a way to eliminate y. Okay, and these ones we actually don't need to multiply by anything. So just start by adding equations 1 and 2. So that's going to be equation 1, equation 2, and this is equation 3. Okay, so just by adding equations 1 and 2, I automatically get rid of y because they have opposite signs on them. So y cancels out. You're left with, we're adding, so x plus x will be 2x. 2z plus z will be 3z. And of course, 9 plus 1 will be 10. So I have taken 2 equations and boiled it down to one equation with 2 variables, right? Let's call this equation 4. I need to do this one more time. So since I used equations 1 and 2 in this setting, for my next pair, I will use equations 2 and 3 because we haven't used equation 2 so far. And using equations 2 and 3, again, you can see we can get rid of that y straight away. So we are going to use equations 2 and 3 now. That's going to be x minus y plus 2z equals 1, x plus y minus z equals 5. So adding those 2 equations will end up giving us, again, y cancels out, x plus x is 2x, 2z minus z is just 1z, and 5 plus 1 is 6. Let's call that equation 5. So this was your step 1, which said reduce the problem to a system of 2 equations in 2 variables, which is what we have. 2x plus 3z equals 10. 2x plus z equals 6. This is our equation 4. This is equation 5. Okay? Which variable do you think will be easy to eliminate at this point?
2
The 2x, yeah.
or x again.
So what should we do?
Multiply by -1.
Yeah, remember you have to have opposite signs for your variables to cancel out. So 2x will cancel out. Again, doesn't matter which one, but I'm going to take my second equation and multiply it by -1. So keeping the first equation the same. Multiplying second equation by -1 will give us negative z and -6. Okay, there we go. Positive 2x, negative 2x will cancel out. 3z minus z will of course be 2z. 10 minus 6 will be 4. And as you can see, we can go ahead and find out what the value of z is going to be. Now that we have the z, what's the next variable we can find out?
X.
X, yeah, because we still need to stick with this same system here and find our x. And again, you can use equation 4 or 5 to find the x. So I'm actually going to use 5, which is 2x plus z equals 6. Z is 2. So what does your x come out to be?
2.
Yeah.
Now can you just plug those back into equation 1?
Yeah. So now we have found 2. We need to find the third one. So for y, obviously we need to go back since both equation 4 and 5 does not have a y in it. So yeah, you can use any one of the original and use that equation 1. So let's use that. So what do you get for y?
5.
Yeah, very good. Again, remember this is an ordered triple, so you do x, y, and z in that order. So 2, 5, and 2. And again, normally make sure you check your answer, but for time reasons, I'm not going to do that.
So why did you go back to the original equation to check for y?
Because our equations 4 and 5 don't have a y in it, right? So that's why to find the third variable, we always have to go back to the original equation. Okay, I actually do want to look at an example for infinite number of solutions. This is basically the idea where your plane should be intersecting at a line, okay? So if there are 2 planes, they will also intersect at a line. If there are 3 planes, they can also intersect at a line. So I'm actually looking at the example with the 3 equations. Again, obviously our steps are going to be very, very similar to what we just did in example 1. So in example 4, we can actually eliminate y or z from the way it's given to us. You know what? to eliminate z this time since we did y for the other example. Again, equation 1, 2, and 3.
For 4, won't it eliminate x or y and z? Won't you get x off adding 1 and 2?
Okay, so what do you get?
X, 2x equals 4, and then you get x equals 2.
So both y and z cancel out. 2x equals 4. X equals 2. So these ones will actually function a little bit different. So let's see, we added equations 1 and 2. Oh, Lordy. Let's see what happens if we add equations 2 and 3. What do you think happens here?
You're just gonna get the same answer.
You getting the same answer?
You get the same answer.
Which you should. If you get different answers, we did something wrong. Okay. So here's the interesting part that happens with this. Because remember, this is the example where we have infinite number of solutions, right? We're basically saying this is meeting at a straight line, our 3 planes are. So what's happening here, since we basically ended up getting the same value for x when we tried to do the 2 different sets of equations, this is actually the indication which is telling us that we are actually looking at infinite number of systems. Because remember, on the exam or even in homework, they're not going to tell you what system this is, right? So we just use the same method to solve it. So since we didn't get a different answer for our second equation, this is where you're basically going to take all of the 3 equations. So that's our first equation, which will be x is 2. So that's x plus y plus z equals 1. Our second one will be 2 minus y minus z equals 3. And then 3 times 2 plus y plus z equals 5. We will literally be solving this either for y or for z. And once you actually look at your homework for my math lab, this will become -1. Right? Again, you should expect that because we are talking about infinite number of solutions. Now here's the part where you got to be careful about how do you write your solution set, because we're not going to get one number for x, one number for y, one number for z here. So a lot of times your My Math Lab tells you how it wants you to write the answer. So sometimes it will ask you to write the answer in terms of x, and then it gives you blanks for the other 2. Okay, sometimes it will ask you to write it in terms of y, and same thing with z. So you actually have to see for which equation they're asking us to write this for. So for this guy, I will show you how we write the solution set. So we actually have a static number for x. We know x equals 2. So that value will stay the same. Now for y, if they want us to write the equation in terms of y, you're actually going to write just y for the y variable and then rewrite this equation by getting y by itself, sorry, z by itself on one side. So if I get z by itself on one side, that means we are doing -1 minus y, and that'll be the same no matter which format you go with. So if they want our equation in terms of y, then you are writing z in terms of y, okay? So a lot of times they actually tell you which variable they want you to solve the other ones for. If they ask us to write this in terms of z, that means we write the variable z as it is and solve this relationship here for z, which means you want to get y by itself, which will end up giving us -1 minus z. So we get y in terms of z. So are they asking us to write this equation in terms of y? Are they asking us to write the equation in terms of z? Sometimes all three of them can be unknown values, so they can also write the whole equation in terms of x. Just depends, but since we had a static value for x here, we obviously need to write x equals 2, but then the other two variables can be both in terms of y or both in terms of z. Okay. For the inconsistent system, and I'm not going to take up your time, for the inconsistent system where the planes are basically parallel to each other, which would end up looking parallel, or it can also actually end up looking like this, where we have 3 planes. 2 of the planes are intersecting with each other, but all 3 of them are not intersecting at one point, right? So they can be parallel, which would be the most basic thing to imagine, but it can also be something like this. So you can see all 3 of our planes are not meeting at one point. So what's going to happen if you try to solve something like this? You will actually end up getting 2 different values of x here. So they will not come out to be the same. So if you get same values for x, or whichever variable ended up staying at this point, if you get the same answer, you're looking at infinitely many solutions. That means we end up writing our answer in one of these formats, right? If it was like the previous example where you actually were able to get 2 separate equations for 4 and 5, then you're going to get one single order triple. For inconsistent system, you're going to end up getting 2 different values for x, which will tell you, okay, our equation is not working. So that's the one where you end up writing no solution. Trying to think how it does that. I think it actually gives you an option of no solution, if I'm not mistaken, in my math lab. So what I'm actually going to do is take some of the problems out from 5.2 and only keep examples for they meet at one point, they have infinite number of solutions, or they have no solution. I'm going to take all the other homework problems out because I at least want you to see what these sections look like, okay? So again, guys, remember that you will be taking the test for this starting anytime tomorrow.